Hello, dear. Good morning, kids. Today we're going to talk about the isosceles trapezoid. In isosceles trapezoid has a specific properties. Um, it has it's a quadrilateral with only one pair of parallel sides. But also, isosceles trapezoid has legs. They are the same and two parallel sides. Okay, let's start. If we would like to draw trapezoid, let's choose one leg to be 10 centimeters. So I'm gonna do and draw the parallel to the edge. Okay, so if this is 9, I need some more. So here's the 10 centimeters one leg or one side of trapezoid. Okay. And we can label as like B1 or base 1 is equals to 10 centimeters. Okay. Now we can think about the angle of the or trapezoid. So we could, if I choose to on this base to be, let's see, 60 centimeters, 60 degrees angle, I can use my protractor the other way. We can start from this here, and I would like my angle be 60 degrees. So I'm going to go 0 line. It's from this point right here. And then I'm going all the way to 60, and 60 is right here. And I'm going to draw connect the dots, and that will be my one leg of my trapezoid. Let's see if maybe I have 5.5 centimeter, if I would like that to be 5.5, 5 and 5 whole centimeters and 5 more millimeters, about right here. Okay, now I know that this angle here is 60 degrees. I can label it. And then I know this one is also going to be 60 degrees. I have to move the paper a little bit in order to do that. I'm going to make, because the angles on the legs are congruent. So right now I'm going to make this 0 is inside, and I can look, and oops, I moved the paper so it's not okay. There you go. All the way to 60, it's right there. So this angle on about the other side of the leg is going to be congruent, which means the same. And then I can say that this is also 60 degrees angle. Okay. All four angles need to be 360 degrees. So I can say, I can figure it out. If I have the 1660, that's 120 degrees. I can think about 120 and what 120 degrees, and what will make all 360 degrees. So the rest of them needs to share 240 degrees. So these two have to share 240 degrees angle. So that one would be 120 and other one will be 120. But I can use my little triangles to connect the next 2 points. So if I know, then this will be also 5.5 centimeters. So it's going to be right there. I can use a parallelity. So this point A and line segment AB will be parallel to segment CD. So I can do and drew the line. If I make parallel to AB, I can take my triangle slowly and it will be parallel to this line segment. So we can say this 2 points A, B, C, and D can, so DC is parallel to AB. Okay. I can do ADCB or ABCD trapezoid, isosceles trapezoid. And then I can measure the sides. So if I look, this one's 10, and then this is going to be about 4.5 centimeters, a little more, 4.6. 4.6 and 5.5. Okay. 4.6 centimeters, and that is a base 2. Base 2. And the leg 1 we can call A. A is equals 5.5 centimeters. And this is also A because they're the same. 5.5 centimeters. Okay. Now I can check that was my calculation correct. I can see that here I have this angle. It's going to be from the outside all the way to 120 degrees. From this point right here, all the way to 120 degrees. So this angle is 120 degrees. And of course, this one is also 120 degrees. So the angles on legs are on same legs are congruent, 60 and 60 degrees, and then another leg 100 base. Other base are also 120 and 120. We also can conclude that opposite angles are supplementary because 60 and 120 make supplementary angle 180 degrees, or we can say that the angles on the leg are supplementary angles. So I usually color this same because these two are the same, and then these two are the same. Okay. We also can explore their diagonals. So if we look in through diagonals on isosceles triangles are congruent. So diagonal from D to A will intersect the AC diagonal, and the diagonals will be the same length. They are congruent. Okay, we can label our isosceles trapezoid. If we correctly label, we can say that A C line segment, like that, is parallel to DC line segment. We can say that that AD line segment is congruent, and this is the symbol for congruency, is congruent to CB line segment, and then that is equals 5.5 centimeters. Okay, we can say that angle A is congruent to angle B, and that both are equals to 60 degrees. And then we can say that angle D is congruent to angle C, and each of them is 120 degrees. We can say that line segment, for example, AB is equal to 10 centimeters, and line segment DC is equal to 4.6 centimeters. Okay. We can say that the D diagonal 1 and diagonal 2, so we can say that D1 is congruent to D2. D2. We can explore the sides. On the side, we can write that there are 4 sides. So if we write the definition, a quadrilateral with only one pair of parallel sides, but for isosceles trapezoid, we have 4 sides, and 2 sides are congruent to and 2 sides parallels. Parallel sides, or one pair of parallel sides, and that was the one pair of parallel sides. So when I show to the students, I usually use this. So if this is one side, and here is the parallel sides to it, I can move it down, and I can slide that to this. So these are the pair that are parallel. Pair of parallel sides. Okay, if we talk about angles, okay, angles, we can say there are 4 angles, 2 obtuse and 2 acute. So these are acute, and these are obtuse. obtuse and acute angles. Both are obtuse and these are both acute, which means less than 90 degrees and more than 90 degrees. We can check that property by using a paper. So if we look this angle, it's about right here, the line. So the 90 degrees is about right here. So this angle is less than 90 degrees. And we can show that to the kids if we fold it. So it's less than 90 degrees. If we take this one here and measure the angle, we can see that if it's 90 degrees, it would be about right here. But the angle is much bigger, for this much bigger than the 90 degrees. So this is obtuse angle. Obtuse and to acute. Okay, we can say that two adjacent angles are supplementary, or two opposite are supplementary, if we wish to say that. About diagonals. Okay, they have two congruent diagonals or diagonals. Okay, we also can explore symmetry. So if we explore a symmetry, the line through the center of that could be our line of symmetry, because it will create exactly two identical parts of this trapezoid. So if I take here 4.6, that would be a 2.3 would be the midpoint, and I know that this will be my the line of symmetry. I can do the dashes and even further up. So that will be L1, or line symmetry, one line of symmetry. So it's only if I try this way, this part is smaller than the part down. If I try diagonal, it's also so the only, there is one line of symmetry, one line of symmetry. And we can prove it by using our putty paper or see-through paper. I already trace the trapezoid around, and then if this is my line of symmetry right here, I would be able to fold the paper and without overlapping. So I can see that my line symmetry will exactly fold this shape into the half without overlapping. So there is one line of symmetry. If I drew the line through that trapezoid and I fold it, the edges will be not overlapping. It will be perfectly matching. So that's one way. If I try the other side, you can also, you see, if I try to draw line through this midpoint, then the sides will be overlapping. So you can see that this part of the triangle trapezoid will be smaller than this part on the bottom, and they're overlapping, so it cannot be. If I try other side as well, it's now matching, is overlapping. So we proved that there is only one line of symmetry in this case. Okay, we also can explore a rotational symmetry, and rotational symmetry we could do by tracing trapezoid and then putting that on the top above the and if I put my finger in the middle and try to rotate, let's see if that gonna be coming to the same spot for all rotation. 90 degrees, no. 180, no. 270. So I move all shape around, and it didn't come to the same spot, same exact shape. So this trapezoid do not have a rotational symmetry. It has a zero rotational symmetry. Zero. Zero rotational symmetry. I hope that you like our isosceles trapezoid, and this would be our conclusion. I hope you like it. Thank you very much for listening.